Let's derive the logarithm base change rule, and in order to do that, we're going to start off with an exponential function. We'll call it y to the r equals x. And these values that I've chosen, the y, r, and x, are somewhat arbitrary other than they're easy to tell apart. I wouldn't make the letters very different so that the work was clear. They have no particular value. I could use hard numbers. I could say, y equals 10, r equals 5, and x equals whatever 10 to the 5 would be 10,000. But I wanted to solve this generally because I think it will be much clearer if I do it that way. So don't worry about, why is this y, why is this r, why is this x. They can all be variables, every one of them. Every one of them can be constants. I just chose these letters because they look very different. And it's best to solve this problem generally. We're going to start off by taking the logarithm with a base of a, which again is just another number or variable. I'm just choosing letters that look very different for clarity purposes. Log base a of both sides, so we have y to the r, and that's going to equal log base a of x. Now, using the logarithm power rule, we can take this r down and say r times log base a of y is equal to log base a of x. And furthermore, we can divide both sides now by log base a of y. So we get r equals log base a of x over log base a of y. And now we've solved this in terms of r, but what can we do with r? Well, up here, we're going to use a similar technique to we did in the let me think. Well, we used a similar technique before, and we'll do it again, so it doesn't really matter. So we have y to the r equals x. Remember that in logarithmic form, we have all the information to state this as such. We have log base, bring down the base of the exponent, so we have log base y of x is equal to r, because logarithm is solving for y to the what equals x. So y to the what equals x is r. And since down here we have r equals this whole expression, we can just replace r with log base y. I'll make this a little neater. Log base y of x. And if you notice, we've done a base change. We had log base of y, now we have log base of a. We have our original function turned into log base y of x. So anyway, long and short of it is we have the base of y taken into the denominator. The original value of x was maintained in the numerator, and we have an a of our choice. We get to choose which a is convenient for us, and we are done.